everyone. My name is Amber Armstrong, and today I will be performing my favorite lab of the semester, TLC of food dyes. So first, I want to start off by saying this lab required a lot of prepping, and right now I am going to prep the Kool-Aid samples. We have 3 Kool-Aid samples: orange, strawberry, and grape. So right now I am separating each Kool-Aid sample into 3 small cups. As you can see, I labeled the cups so that I know which Kool-Aid sample is in which cup. Now, at the end of the experiment, we want to see which food dyes are present in each Kool-Aid mixture. Oh my gosh, I was so upset. This is one of my favorite sweaters, I'm not gonna lie. But it's okay. I came back and I came back better. So after this is what the Kool-Aid sample should look like once you're done. Next, we prepared the NaCl water, sodium chloride water. Mix that together. So next, we want to prepare our chromatography strips. These are going to be our stationary phase in the TLC experiment. And then we're also going to prepare our pipettes. These are going to be used to transfer our liquid food dyes and our liquid Kool-Aid samples to the chromatography strip. So now to begin the experiment, we're going to separate each food dye color on a piece of aluminum foil. The food dyes that we used in this experiment were yellow number 5, blue number 1, and red number 4. And what we're going to do is find the retention factor of these dyes and see if they match any of the retention factors in the dyes present in the Kool-Aid mixtures once we separate out the Kool-Aid samples. Next, we want to take our sodium chloride water that we made at the beginning of the experiment and put 3 drops of that in 3 test tubes. We're then going to take our chromatography strips with the food dye on them and place them into each test tube. What we want to see is that each food dye travels up the chromatography strip at different rates. This is going to determine our retention factor of the food dyes, and this is going to determine if any of those food dyes are present in our Kool-Aid mixtures. Here's a picture of my results after dipping the food dyes into the solvent. Next, we're going to repeat the same steps, but instead using the Kool-Aid samples. A key note here that you want to make sure that your sodium chloride solution is touching the tip of the chromatography strip. I performed this experiment twice actually, and the first time I had to redo it because the sodium chloride solution actually wasn't touching one of the strips all the way, and it caused my food dyes to travel at a much slower rate than the other food dyes. Results after dipping the Kool-Aid samples in the sodium chloride solution. As you guys can see, there are food dyes in each Kool-Aid mixture. That is all that I have for you today. I hope you guys enjoyed my presentation. Thank you all for watching.